Have you ever looked up at the sky and wondered why it's blue? From the vibrant blue of a summer afternoon to the fiery hues of a sunset, the sky's colors have captivated us. But what's the secret behind this celestial artistry? The answer lies in the fascinating interplay of light, air, and a phenomenon called Rayleigh scattering. It's a story of light waves embarking on a journey through our atmosphere, bouncing off tiny air molecules. And the result, a breathtaking spectacle of color that paints our world in shades of blue, orange, and everything in between. Imagine the sky as a giant prism, splitting sunlight into its component colors. And just like a prism reveals the hidden colors within white light, the sky reveals the secrets of light's interaction with our atmosphere. So, next time you gaze up at the sky, remember that you're witnessing a scientific marvel, a testament to the beauty and complexity of our universe. It's more than just a pretty picture, it's a story written in light. A story that we're about to unravel together. So buckle up, fellow explorers, as we embark on a journey to discover the science behind the colors we see. Light, the very essence of vision, is more than just what meets the eye. It's a wave, a ripple of energy traveling through space at an incredible speed, and like any wave, light has a wavelength. The distance between two consecutive peaks. This wavelength determines the color we perceive. Think of it like a musical instrument. Different wavelengths produce different notes, and in the case of light, different colors. Visible light, the kind we can see, is just a tiny sliver of the electromagnetic spectrum. This spectrum includes everything from radio waves, the longest wavelengths, to gamma rays, the shortest. Red light has the longest wavelength in the visible spectrum, while violet has the shortest. And when all these colors combine, they create white light, the light we see from the sun. It's in the atmosphere that the magic happens, where sunlight interacts with air molecules to create the colorful spectacle we call the sky. Now let's talk about Rayleigh scattering, the phenomenon responsible for the sky's blue hue. Named after Lord Rayleigh, this type of scattering occurs when light waves interact with particles smaller than their wavelength. In our atmosphere, the light waves scatter off tiny nitrogen and oxygen molecules. Shorter wavelengths, like blue and violet, are scattered much more strongly than longer wavelengths, like red and orange. This preferential scattering of shorter wavelengths is why the sky appears blue. The scattered blue light reaches our eyes from all directions, giving the sky its characteristic azure hue. So, even though violet light is scattered more, we perceive the sky as blue. But what about those stunning sunsets and sunrises, when the sky explodes in a riot of oranges, reds, and pinks? The secret lies in the angle of the sunlight. When the sun is low on the horizon, sunlight has to travel through a much thicker layer of atmosphere to reach our eyes. On this longer journey, more of the blue and green light is scattered away, leaving the longer wavelengths like red and orange to dominate. That's why sunsets and sunrises appear reddish-orange. The more atmosphere the sunlight has to travel through, the redder the sky becomes. So, the next time you witness a breathtaking sunset, remember that you're seeing the result of sunlight's long journey through the atmosphere. It's a testament to the interplay of light and air, a reminder of the beauty and complexity of the world around us. Rayleigh scattering isn't just confined to the sky, it's a phenomenon that occurs all around us, often without us even realizing it. For instance, have you ever noticed how the air around a distant mountain appears bluish? That's Rayleigh scattering at work again. The blue light from the sky is scattered by the air molecules between you and the mountain, making the air appear blue. It's the same principle that makes distant objects appear hazy or bluish. Another example is the blue color of some gemstones, like sapphires. Tiny inclusions within the gemstone scatter blue light, giving the gem its characteristic color. Even the blue color of some animals, like bluebirds and blue morpho butterflies, is due to Rayleigh scattering. Microscopic structures on their feathers or wings scatter blue light, creating their vibrant colors. So, there you have it, the science behind the sky's ever-changing colors. From the vibrant blue of a summer afternoon to the fiery hues of a sunset, the sky is a constant reminder of the fascinating interplay of light and air. Rayleigh scattering, the phenomenon responsible for the sky's blue hue, is a testament to the power of light's interaction with matter. But the sky's colors are more than just a scientific curiosity. They're a source of inspiration, a reminder of the vastness and wonder of the cosmos. And here's a fun fact. On other planets with different atmospheric compositions, the sky can be different colors. For example, on Mars, the sky can appear butterscotch yellow or even reddish-brown due to dust particles suspended in the atmosphere. So, while our blue sky is a familiar and comforting sight, it's just one of many possible sky colors in the universe. Learn with Rishi? Subscribe now.